Okay, so my name is Jarosław. I'm Principal Solution Architect at Red Hat. I'm focusing mostly on the application platform. So this includes OpenShift Container Platform and Red Hat JBoss middleware technology. I'm working with the clients mostly in the region of Central Eastern Europe, but also I have some experience with some project experience in the Asia, Middle East, and the US. And I have over 20 years experience in application development and the architecture of the large systems.
Okay, and my name is Marcin Kubacki. I'm Chief Software Architect at Storware, and my main experience, well, the area of experience is virtualization, middleware, and software development. So I have experience in many different areas and how to join these together. So now we have introduced briefly the OpenShift pipelines. So let's if you could just continue from this moment.
Yeah. So just last sentence about this slide. So there are a number of tools that you can use to manage your pipelines in Tekton. So there is the web interface, web console. There is a command line, dedicated command line interface, and also there are some plugins for IDEs, like for example the Visual Studio Code plugin.
Okay, so now maybe let's have some short introduction to the architecture, key definitions, key concepts that we have in pipelines.
Yeah, so we have like two stages. So first we need to build our pipeline and then we execute it. So when we define a pipeline, the pipeline will consist of sequence of steps, which are called tasks. So you can also implement some more advanced routing scenarios in the pipeline. So like parallel execution or conditional execution of the tasks. Once you create a pipeline and you define tasks, the next step will be to execute the pipeline. So for that you will again create some additional objects, configuration objects, which will be picked up by the operator, pipeline operator, which is responsible for execution of this of the pipeline in the Kubernetes. So for that, what you will define, basically you will define, first of all, you will need to define a set of resources that will be most probably consumed by the pipelines or created by the pipeline. So objects, resources like, for example, the Git repo, location information, or the image or images, container images that will be created as part of the pipeline. These are the examples of the resources. And then you define a pipeline run object where you might set specific parameters for the pipeline. You can assign resources, and once you create this object, it will be executed by the pipeline operator, and the pipeline operator will start executing tasks using the separate task run objects. And for each task run object, there will be a dedicated pod created in the Kubernetes cluster, which will execute each of the tasks as a separate pod.
Okay, so now maybe a little bit more deep dive into the tasks themselves. So how they organize the actual work that is done.
Yeah, so the tasks are really the key components here, because in the task you will define really the logic of your pipeline. So the great thing about tasks in Tekton is that they can be reused. So you define task once and you can reuse it across different pipelines. So in general, there are two types of tasks. So you have cluster tasks, which are available for every pipeline in the cluster. and there are kind of regular tasks that are just kind of local for a pipeline deployed in some namespace, which is a kind of context to execute a task. So the task can have, of course, the inputs. So they can take some input resources or input parameters. They could produce some outputs. So, for example, if you have tasks where you build the image, the output will be the image that will be built. And also, it is possible to assign external data sources using the concept of workspaces and results, so that you can consume or reuse some data across different tasks within your pipeline.
Okay, so now I guess tasks are reusable components. So are there any catalogs, marketplaces that we can find maybe more of such?
Yeah, so the community of the Tekton project is maintaining a tasks catalog on the GitHub. So you can find there quite a lot of different tasks that you can reuse, which you can see some examples here. So some language specific tasks, or some tasks that could execute different image build tools. And also we in OpenShift we kind of extend this community catalog, and we have added number of tasks which are kind of more specific to OpenShift, like for example execution of source to image tooling, which is OpenShift specific, or the task where you can execute OpenShift command line interface OC. These are kind of major sources that you can reuse, and these are two major catalogs that are available.
Okay, so now how to enable OpenShift pipelines in the OpenShift?
Yeah, so as I mentioned in the beginning, the execution of the pipelines is managed by the operator. So the only thing you need to do in order to enable OpenShift pipelines is to install the operator. Once you install the operator, your cluster is prepared and configured to execute pipelines. So there are no more additional steps. Also, after you will install the operator, in OpenShift there will be a new configuration specific to pipelines enabled in the web console. So here you can see a screenshot of the pipeline builder, which is visual tool that you can leverage to kind of build pipelines in kind of agile and visual way.
Yeah. Okay, so I guess we can have a demo show right now.
Yeah, exactly. And this is, I think, the good time to show you how this really looks like in a real world. So I will switch now to my OpenShift console. Okay, so first I will log in as a cluster admin just to show you the operator configuration. So if you know from the previous webcast, we have the integration with the operator hub, which is a kind of repository of the operators, and here is the OpenShift Pipelines operator available. So the only thing you need to do here is, of course, you need to be logged in as a cluster admin, and then you click here install, and this will set up operator for you. It is automatically enabled in every namespace or project in the OpenShift. So it is kind of cluster-wide operator. So once you install the operator, you will see in the web console there will be a new menu available, the pipelines menu in the administrator tab, and also in the developer view, you will see the pipelines as well. And basically, this is where I would like to start creating a new pipeline. But first, I will log in as a regular developer so that you can see that it works for kind of regular user, not only the cluster admins. Okay, so let's see what we have here. We have a couple of pipeline definitions. Some they were executed. You can see some statuses. So let's start creating a new pipeline. So the pipeline will be we'll create a project. I will build an image. We'll deploy an application from that image. So the container will check if the project is working well, and then we'll delete kind of the whole test case for automated with the pipeline below. Okay, so the first task for us in the pipeline, maybe before I start creating tasks, I will define some parameters. So we will need 2 parameters. So the application name. So I will use the Quarkus application. So hopefully you remember the Quarkus framework, which we introduced also some time ago. So two parameters. First is the application name. The second is the image name. Tracing. Okay, then we need to add some resources. So we want to build an image in a pipeline. So we need to specify the source, Git sources, the repo where the sources of our application are stored, and also I will specify the image that will be created in the pipeline, the image resource. Okay, so that's what we need here, and now we can start configuring our pipeline. So the first step, we will use a task OpenShift client. So you can see here there is a set of tasks available. So the catalog of tasks have been is also installed into the as part of the pipeline installation. So let's call it create app, and here we're going to call the OC ADM new project. So we create a new project. We use the name that will be specified as a parameter. And also I will add here a flag to set my developer user as an admin of this project. So you might wonder why I can use here the ADM command, which is reserved for the cluster admin. This is because these tasks will be executed with the permission of the pipeline service account that is created in every project. And once the cluster admin grants the permissions for this service account to execute the administrative commands, I can use here the ADM subcommand of the OC command line. Okay, so this is the first step. In the second step, I will build the image. So here I will use the source to image Java 11 task. So this task needs to be also configured. So I will skip TLS verify for the quick demo. And here these tasks, as you can see, this task expect some input. So the input for this task must be a Git repo resource. That's why I specify this resource in the beginning. And also it creates an output resource, and this resource is an image that will be produced by this task. And also at the end of the task, the image that will be built will be stored in the repo that is specified in the name of the image here that I will define later. Okay, so this is the second task. So in the first task, we will try to deploy the application based on the image that we created. So again, OC, we change the name to deploy app. Here the command is OC new app image name. So again, I use the parameter image name, and I need to specify a namespace, because again, you need to remember that by default, every task in your pipeline will be executed in the namespace in the project where this pipeline is deployed. So in my case, this is a CD project. So here we need to specify the project name, which is again based on the happening variable, and I will copy that parameter to use it later. Okay. Next step is to verify our deployment. So here we can again leverage. We can leverage here again OC, but this time we're going to use subcommand status with the flags jest, and also we need to specify the namespace. Okay, and the last step after we verify, we know that the application is successfully tested and verified. We will destroy our project. So again, delete app, OC delete project, and we again use the variable. Okay, so that's it. This is our simple pipeline. There were no errors. So if you would make some typo, like you would provide the wrong parameter name, or this kind of errors would be cached by the tooling here. So it's quite easy. So now, once we have the new pipeline, we can start it, so we can execute it. As you can see here, using the visual, the web console, you will see the form to provide the parameters and the resources. So I have defined in advance some resources that are pointing to my Git repo, and also that are pointing to the image registry where I want to store the image that will be built. And here we don't need to provide the credentials, but there is also a possibility to define a secret, Kubernetes secret that stores the credentials to access both the Git repo and the image registry. So now the pipeline has started. So we can observe what would be happening here. So we can click here, and we see the log of currently executed tasks. So the first task, create app, was pretty straightforward. We just executed the OC command, which has created for us the Quarkus app project. So we can now switch to the administrator view, and we should see that the project Quarkus app is here, created less than a minute ago, as you can see. Now, coming back to our pipeline, here it is. So we need to find the pipeline run. And here we can see the second task, which is source to image. So this task consists of multiple steps. So I didn't mention that that you can create in the task you can create multiple steps, and every step will be executed in separate container within one single pod. So this one is quite heavy. So what we can do here, we can switch again to the administrator view, and we can try to find a pod that execute this task. So we should see it here in the pods. Okay, I see here pending, which is kind of a bit of scary. So okay, so we have image pullback error here. So it means there is some network connectivity issue between my environment and the repo where this builder image is stored. Hopefully, it will be somehow solved. But if not, I can try to show you how this looks like in the other pipeline that I have executed before. When I was preparing here for this demo. Okay, so let's see here. The Quarkus pipeline is the one I have created as a test. As you can see, it has pretty much the same structure. You can check here the runs, and the last run, this one, we can see here that it consists of multiple steps. So unfortunately, the logs are not anymore available, but every step was executed in a separate container, but within the same pod. So it means that you can share the context of the execution. So, for example, if one step will produce some, let's say, some binary file, it can be stored in the shared volume, and the other step can access this volume and execute some task. Can reuse this asset. All right, so this is what should have happened also in the pipeline that I have just created. So let's give it some second chance and see if it managed to pull the source. I'm afraid not. So we have some network connection issue here, unfortunately.
In the meantime, maybe another question. So we have so far seen steps that they are actually run one by one after the other. Is there option to run simultaneously several steps?
Yes, of course. So if we go back, let me just quickly check the pod. Not the project. Yeah, it's still pending. So I'm afraid we will not see how this executes. So
well, I believe that it's going to work exactly like you showed before.
If we go back here to our pipeline definition, and we can edit this pipeline, and here we can add some parallel tasks here. So say we don't want only to create a app here, but for example, we can execute
Okay, let's see. So there are simultaneously executed tasks, and are they waiting? Let's say, so is it the S2I Java 11 is going to wait until all of the preceding tasks are going to complete, or how does
yes, in this scenario, yes, but you can also implement a conditional tasks.
Mm-hmm.
So you can define. Unfortunately, not using this visual editor, but you can define a condition that needs to be met to execute the task. So
we define them in YAML form, right? Can you?
Yeah, of course. All the tasks are generated. I mean, all the pipelines are generated as a YAML files. You can also edit the YAML files directly if you want to, but here you can see that all the tasks, all the pipeline here is saved as a YAML file.
Okay, and can I later somehow connect this pipeline to some Git, for instance, so that I can have versioning enabled for pipelines?
Yes, I mean you can apply any, for example, the GitOps approach here. So you can store this pipeline definition in the external Git repo, and you can use the tool like GitOps tool, like for example Argo CD, and import or deploy those definitions of the pipelines into your cluster. So definitely you can. These are just regular YAML files. Everything here is a YAML file, so you can easily manipulate it just much the same way like you deploy the applications into the Kubernetes.
Okay, so I guess that summarizes briefly what we have in our presentation today. So now it's time for Q&A session. So please type in any sort of questions that you have here in the chat, so we can briefly answer them. Okay, so if there are no questions for now, you can always reach us via social media, and we'll try to answer them later. So thank you for watching, and stay tuned for the next webinar.
Thank you.